Hi, this is example 13.8 in your textbook. 13.8 talks about how to do the shear diagram, and then it's also 13.14, example 13.14, which shows you how to do the bending moment diagrams. Now, if you follow along with your guidelines, the first step to tackling one of these problems is to calculate the reactions. I provided this piece of paper, so you already have the load diagram. Okay, so first of all, the reactions. Okay, so I got 4 kip per foot, that's this distributed load here, and then 10 times 10 feet is the length of that load, so the total of that load is 40 feet. So now we're going to sum the moments about point A. I always start with the moments about point A, just to make sure that I'm using a consistent formulation. Okay, so the reaction at B times 25, which is this total distance here, that's going to be equal to the moments counteracting that reaction moment, okay? In which case I have the moments due to this distributed load, the moments due to this concentrated load, and the moments due to concentrated load at point 2. Okay, so I'm replacing the distributed load with a 40-pound load at 5 feet away from point A. So essentially what I'm doing is the centroid of this 10 feet is 5 feet, and the total load is 40. So I'm replacing the distributed load with essentially a concentrated load at 5 feet. So that's this 40 times 5. 8 times 15, 8 is P1, 15 is the distance from point A to where this load's applied, and then 8 is due to P2 times 20 feet, that's the distance from point A to where P2 is applied. So I solve that for RB and I get 19.2 kips. Next, I'm going to solve for reaction at A, and I'm just going to do that by summing the forces in the vertical direction equals to 0. So I have 40 for the distributed load, I have 8 for the concentrated load, another 8 for the concentrated load, and I'm going to subtract 19.2 for my reaction at B, and that gives me 36.8 kips for the reaction at point A. Okay, so now, again, we're going to have to find these points of zero shear. Okay, so if I'm starting at 36.8 here on my shear diagram for A, and my load here due to the concentrated load is a total of 40 pounds, 40 kips that is, by the time I get to 10 feet away, I'm going to cross the zero line because 36.8 minus 40 is negative 3.2. So here's negative 3.2. So I start at 36.8. Concentrated load is at an angle here, and then I'm going to end at negative 3.2. The next one, so negative 3.2, I am not going to have any loads until I get to the 8 kip here. So I'm going to go over at 3.2 up to this point, and then 8 kips. Okay, so that would be the 3.2 minus another 8, that's 11.2. And then here's another 8, so 11.2 minus 8 is 19.2. Okay, so that tells me that 19.2 is correct because that's also my reaction at B, 19.2. So that's how these static equilibrium equations self-check themselves. Okay, so when you're constructing a shear diagram, here's what I want you to see. I want to see the 0 here. I want to see the axis, okay, of 0. I want to see V, this is a label, V and what units they are in kips, and I want to see the loads drawn like I'm shown here. And then when you get to do the moments, we need to find this point at where the shear crosses the 0 axis. Okay, so that is the shear diagram. Let's talk about what our bending moment diagram looks like. I'm missing the M here, and the units would be kip feet. Okay. Okay, so I'm going to do this by finding the areas. First of all, I'm going to find where is the shear 0. And to do that, I'm just going to set a proportion. So 36.8, 0 equals 36.8 minus 4 times x. When I solve that, I get x is 9.2. So therefore, my shear diagram is going to cross 0 at a distance of 9.2 from point A. That's what this is here. Next, I'm going to find my areas. I labeled A1. This little bitty area here is A2. I'm calling this A3, calling this A4, calling this A5. So area A1 is 1/2 times the quantity 9.2, which is the length, times 36.8, which is the height. So essentially it's the area of a triangle. And I get 169.3 kip feet. Area 2, on the other hand, is 1/2 times 3.2, negative 3.2 here, times 0.8, which is this distance here, and I get negative 1.28 kip feet. Negative because it's below the 0 line. Okay. A3 here is negative 3.2 times 5, which gives you 16 kip feet. A4, the same way, it's 11.2 times 5, it's just negative 56 kip feet. And then A5 over here is 19.2 times 5, or negative 96 kip feet. Okay, so then here's my moments. I'm starting with the 169.3. That's at the point where my shear diagram crosses the 0 line. So that'll be my maximum moment. And then from there, I minus 1.28. So I 1.28, which is 168, is the next point. Next one would be 168 minus A3, which is 152. The next point would be 152 minus 56, which is A4, which is 96. And then finally, this A5 is negative 96, which means my bending moment goes down to 0. Okay, so in the homeworks, I provided you these sheets to fill out. It should help you because you don't have to draw your load diagram. You can just take the sheet of paper I've given you, you can print it out, and you can extend these vertical lines at these points and generate the homework assignments just like I'm showing you here. Okay, so if you got any questions, we can talk about this in class tomorrow. Thank you.